Well, what is up, class? Today we are talking about side, angle, side, 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 angle, 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 side, and using those to determine whether triangles are congruent or not. So right into the problems here. It says, given the triangles A, B, and C and X, Y, Z, what side on X, Y, Z corresponds to side AB? So side AB here, we're going to color yellow. Inside the side on XYZ, which corresponds to AB, might be obvious to you, but it's XY. What I want you to notice here is that when you write the triangles out, like triangle this is congruent to triangle this, AB and XY, they're in corresponding positions even when you write it out just using letters. All right? Kind of interesting. So, what side corresponds to AB? XY. What angle corresponds to angle Z? That's this angle right here. Maybe that's obvious, but it's angle C. And if you look at how you write out the triangles with just the letters, C and Z are in the corresponding positions when you write it out like that too. So we can say angle C. Angle C. So what we just talked about are corresponding parts of congruent triangles, okay? And that'll bring us to the corresponding parts of congruent triangles are congruent theorem. So if two triangles are congruent, then each pair of corresponding sides is congruent, and each pair of corresponding angles is congruent. So it's literally in the name of what this might look like a lot of words, but literally in the name of this theorem is what it means. Two congruent triangles, if you have two congruent triangles, then corresponding parts of those congruent triangles are congruent. That's exactly what it means. So in the if then here down here, it says if ABC is congruent to XYZ, then AB is congruent to XY. Let's see. BC is congruent to YZ. That's not right. YZ. It says AC is congruent to XZ. It also says angle A is congruent to angle X. Angle B is congruent to angle Y. And angle C is congruent to angle Z. All right? So corresponding parts of congruent triangles are congruent. And we're going to use that throughout this section here. The next theorem that we're going to talk about is the side angle side theorem. It says if two sides and an angle between those two sides, let me use a different color here, if two sides and an angle between those two sides in one triangle are congruent to two sides and an angle between those two sides in another triangle, then the two triangles are congruent. That's kind of a lot of words, and it might not make sense when you read it, but let's look at the picture here. So it says if two sides, let's say we have this side and we have this side, and an angle between those two sides are congruent, and so that's in one triangle. Let's say they're congruent to two sides and an angle between those two sides on another triangle, right? So we have the two green sides matching up, the two red sides matching up, and the yellow angle matching up. Then those triangles are congruent. So then triangle RST is congruent to triangle, let's see, XYZ. So for side angle side theorem, again, it's kind of in the name. You need a side, an angle, then a side, where the angle is in between those two sides. And you can even make a note. The angle has to be in between. It has to be in between those two sides, or else the theorem does not work. If you have an angle, then a side, say like instead of the yellow angles we had these blue angles right here, that would not work. We need the yellow angles in between the two sides that we have. All right, so example, it says Mrs. Haberlant has a shiny gold rectangle, but she doesn't like rectangles. To turn her frown upside down, she cuts the rectangle diagonally to make two triangles, her favorite shape. Are these two triangles congruent? If so, explain. To figure out this problem, let's first draw this rectangle that she's doing, okay? So draw the rectangle. There it is. Now, what are some properties of rectangles that we know about? I know rectangles have 90-degree angles. That's supposed to be 90 degrees. And then I know that rectangles have congruent opposite sides, or like opposite sides of rectangles are congruent. So let's say this side is congruent to this side, and this is congruent to that, okay? And in the problem, it says she cut the rectangle diagonally in half. So let's see if I can do that. That wasn't very good. Let me try again. Let me try one more time. That's not better. Let me get out the ruler here and see what I can do. All right, ruler. All right, that's good enough. All right, so she cuts it diagonally in half, and she wants to figure out, let's say, if triangle 1 is congruent to triangle 2. How could we do this? How could we do this? Well, what I see is that in triangle 1 and 2, I see we have a congruent side and a congruent side. I see we have a congruent angle and a congruent angle, and then a second congruent side and a second congruent side. And what we learned about just now, just right above this, is the side angle side theorem, which says if you have a congruent side, a congruent angle, and a congruent side on two different triangles, then those triangles are congruent themselves. And that's exactly what we have here. We have a yellow side, a blue angle, a green side, a yellow side, a blue angle, a green side. So these two triangles must be congruent. Congruent. That should say congruent. Because of side, angle, side. What I like to say is they have a lot of sass. Those triangles are real sassy. All right? Those triangles are congruent because they have side, angle, side congruence. Okay? Next example, it says, given that AB is parallel to CD and AB is congruent to CD, how can you show B is congruent to D? Let's try to do this. All right? It already tells us that AB is congruent to DC. We also know that they're parallel. Whenever we see parallel lines, you always want to be thinking back to parallel lines cut by a transversal. So if you're thinking about parallel lines cut by a transversal, let's say these are the parallel lines. AB and DC are parallel. And then let's say like AC is the transversal. If that's the case, then we can easily say angle BAC is congruent to angle DCA because of alternate interior angles. So let's say that angle BAC is congruent to angle DCA, and I'm just going to make a little note off to the side. Let's say alternate interior angles. All right, pretty cool. Something else we can note here is that AC can be congruent to itself because of the reflexive property. So let's say AC is congruent to CA because of the reflexive property. So if those things are true, we can see that we have a side, an angle, and a side, an angle, and then a side again. So these two triangles are congruent because of side, angle, side. Let's write that down. Triangle ABC is congruent to triangle, what do we say? CDA because of side, angle, side. But again, that's not what we're trying to figure out here. We're trying to figure out how we can show B is congruent to D. Angle B is congruent to angle D. Well, what we can say here is what we learned in the original page here. It says corresponding parts of congruent triangles are congruent. So if we have two congruent triangles, then any corresponding parts of those two triangles are congruent. And that's exactly what we have here. We have two congruent triangles. We can call it triangle 1 and triangle 2 if we wanted to for short. If those two triangles are congruent, then last step here, we can say angle B is congruent to angle D because of corresponding parts of congruent triangles are congruent theorem. That's it. I like to say CPCCCT. That's it. All right, next theorem. It says side, side, side theorem. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So if all the sides of one triangle are congruent to all the sides of another triangle, then those triangles are congruent. So if AB is congruent to ED, if BC is congruent to FE, and if AC is congruent to FD, then triangle ABC is congruent to triangle EDF. There we go. So that we can use this similarly to side, angle, side, whenever proving triangles are congruent, we now have a couple options. We could prove that they are congruent because of side, angle, side, or we could prove that they're congruent because of side, side, side. So let's do some practice on them. So determine whether each pair of triangles are congruent because of side, angle, side, or side, side, side. So looking at number 1, you can see that we have one side and one side, two side, two side, three side, three side. All right. So 3 sides of one triangle are congruent to 3 sides of another triangle. So these are congruent because of side, side, side. Okay. If you look at number 2, we have one side, an angle, then a second side, and a second side. So these ones are congruent because of side, angle, side. All right. Let's look at number 3. These ones here, let's see what order we go in. Here you may be thinking, oh, we have a side, an angle, and a side, an angle, and a side. But the important part to remember is that inside, angle, side, the angle always has to be in between the sides that we have that are congruent, okay? So in order to use side, angle, side, we would need this angle congruent to this angle. And is that true? No. So these are not congruent. Not congruent. Number 4 here, this is an example of side, angle, side. We have side, angle, side, and then we have side, angle, side. So those are congruent because of side, angle, side. All right? What about this one? It says, what additional information is needed to show triangle ABC is congruent to triangle DEF by side, angle, side? So again, what we just talked about is that we need 2 sides congruent, and then we need the angle in between those 2 sides. So in order to make these 2 triangles congruent, we would need AC congruent to FD. That way we have a side, an angle, and a side on both triangles, okay? There we go. I'm going to write that out too. AC congruent to DF, we'll say. There we go. What about this one? It says, what additional information is needed to show ABC is congruent to DEF by side, side, side? Here, we need all 3 sides congruent. So we need BC to be congruent to FE. We need AC congruent to FD. So BC congruent to EF, we'll say. And we need DF congruent to AC. And if those 2 things are both true, then those triangles are congruent because of side, side, side. And then this last short example real quick. Are these 2 triangles congruent? Hopefully by now you're kind of in the rhythm. Yes, they're obviously congruent because of side, angle, side. Well, one more actually. It says any additional information is any additional information needed to show triangle DEF is congruent to triangle GHJ by side, angle, side. What do you think? Just like we talked about earlier, whenever we're using side, angle, side, we need 2 sides, but then the angle has to be in between the 2 sides. So in order to use side, angle, side, we would need angle F congruent to angle J. And is that true? It is not. So since we don't have that there, these are not congruent by side, angle, side. So what do we need in order to make them congruent by side, angle, side? We need angle F congruent to angle J. That's it. All right, so this example here, it says given angle CAE is congruent to angle CEA, and AB is congruent to BC, which is congruent to CD, which is congruent to DE, which is congruent to EA, prove ABC is congruent to EDC. So step 1 is to write down the given. Right now I'm not going to write all that just for the sake of this video, but what you would do is you would write down everything that's right up here, okay? Just the given part. Okay? What I do want to do is go through and mark everything that's in the given on the diagram here. So it says CAE is congruent to CEA. It also says AB is congruent to BC, which is congruent to CD, which is congruent to DE, which is congruent to EA. All right? Let me use a different color for these. Let me use, how about green? Okay? There we go. So, we're trying to prove ABC, this triangle, is congruent to triangle EDC, like that, those 2 triangles. So how are we going to do it? Well, let's say in step 2, let's say we notice that since angle CAE is congruent to since CAE is congruent to angle CEA, can't we say AC is congruent to CE. Let me find a good color here. These two sides are congruent because the isosceles triangle theorem, or the converse of the isosceles triangle theorem, I'm just going to put down the isosceles triangle theorem for now, which says basically if you have two congruent sides of a triangle, then opposite angles of if you have two congruent sides of a triangle, then the opposite angles are congruent. Or the converse of that would be if you have two congruent angles of a triangle, then the opposite sides would be congruent, okay? So isosceles triangle theorem, something like that. That would help us say AC is congruent to CE, okay? And then if AC is congruent to CE, we can see in step 3, triangle ABC is congruent to triangle EDC because of side, side, side. All right, so a little 3-stepper there. Nothing too crazy. Let's move on to the next theorem. It says angle, side, angle theorem. If two angles with a side between those two angles of one triangle are congruent to two angles with a side between those two angles on another triangle, then the two triangles are congruent. So again, that's a whole lot of words to kind of say a simple idea. It basically says if we have an angle congruent to an angle, then a side congruent to a side, and then an angle congruent to an angle, where the side is in between those two angles that are congruent, then those two triangles are congruent. So it's exactly like side, 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 or side, angle, side, except now it's angle, side, angle. And angle, side, angle is another way to show triangles are congruent. So since we have angle, side, angle congruence there, we can say triangle LMN is congruent to triangle RST. RST. Just like that. Okay? So using that idea, let's do this example here. It says, is triangle ABX congruent to triangle BAY? Let's see. Well, it gives us some information. It tells us that angle A is 25 degrees. BAY and ABX. Okay. So, and then this angle A, we have two different angle A's, apparently. Didn't know that. Let's call this A prime. How about that? Let's make this a little easy on ourselves. We have A prime and B prime here. So we have ABX and then B prime, A prime, Y. Okay, that's what we got. So we have angle A is congruent to angle A prime because they're both 25. We have angle B is congruent to angle B prime because they're both 45. And then we can see that AB is congruent to A prime, B prime because they're both 3 centimeters. So here you can see that we have an angle, side, and an angle, yellow, green, blue, and then an angle, side, and an angle on the other one too. We have yellow, green, blue. So these two triangles are congruent because of angle, side, angle. Huzzah, I like to say. There we go. All right, here's an example. It says Bronny James quit basketball. Oh no. And he became a technician. He installed cables from a cell phone tower to the ground and wants both the cables to be the same length. Did he accomplish this? Let's figure it out. So let's see. It looks like we have some cables, a tower, and it looks like the angle created by the cables and the tower are 52 degrees. Those are obviously both congruent, okay? What else does it tell us? Well, it tells us we have a 90-degree angle down here, which means this is also a 90-degree angle. So really, 90 degrees, 90 degrees, those are also congruent. And if you guys remember the reflexive property of congruence, that would say that the tower, or maybe the center line, you can think about it, if we have two different triangles, that is congruent to itself. So because of that, you can say, let's call this triangle 1 and triangle 2. You can say, because we have an angle, side, angle, congruent to an angle, side, angle, then triangle 1 is congruent to triangle 2 there. Okay? Let me write that down. Triangle 1 congruent to triangle 2. And since that's true, we can say, let's say cable 1 and cable 2. Cable 1 is congruent to cable 2 because of corresponding parts of congruent triangles are congruent. So since those cables, right, are just sides of the triangle, really. Since those cables are corresponding parts of congruent triangles, then they are congruent. It's in the name. We have two congruent triangles. We have corresponding parts, so those corresponding parts are congruent. All right, so here's some examples. It says, given the figures, are JKL and MNO congruent? Well, let's figure it out. We have angle J congruent to angle M. We have JK congruent to MN. And we have angle K congruent to angle N. So yes, they are congruent because of angle, side, angle. Huzzah! Now it says, are JKL and PQR congruent? Well, let's take a look. It looks like angle J is congruent to angle P. It looks like JK is congruent to RQ. And it looks like angle K is congruent to angle Q. So originally, you might think, oh man, these are congruent because they both have an angle, side, and an angle. But if you look at triangle PQR, the side is not in between those two angles, right? So since we don't have an angle side and an angle side and an angle on both triangles, these are not congruent. Okay, so not congruent. This does bring us to the angle side theorem. It says if two angles in a side that's not in between, if two angles in a side that's not in between those two angles of one triangle are congruent to two angles in a side that's not in between those two angles of another triangle, then those two triangles are congruent. So here you can see angle U is congruent to angle X, angle V is congruent to angle Y, and then VW is congruent to YZ. This works exactly like side, 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 or angle, side, angle. If we have these properties of these two triangles, then these triangles are congruent, okay? So then UVW is congruent to triangle XYZ. Let's do some examples with it. So determine whether each pair of triangles is congruent by side, angle, side, 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 angle, or angle, angle, side. Number one, it says, or number A, I guess, it says we have an angle, a side, and then an angle and an angle. So these ones are congruent because of angle, side, angle. And I encourage you guys, if you're doing these on paper, to use highlighters to do them. I think that makes it a lot easier personally. Let's look at B. It looks like we have a side and a side, a side and a side, and then another side and another side. So these are pretty easy to see. This is side, side, side. Let's look at C and D. It looks like we have, let's see, a side and a side, an angle and an angle, and an angle and an angle. So this one would be angle, angle, side. Angle, angle, side. And you may be thinking, oh, what about side, angle, angle? Same thing. It's just more common to say angle, angle, side. Side, angle, angle is the same exact thing. So it doesn't really matter which one you write. It's just angle, angle, side is more common. Okay? D here, let's see. We have a side, we have an angle, and we have a side and a side. This one's kind of tricky because you have three parts congruent to three parts, but again, those parts aren't corresponding. See how this angle is in between those two sides, but this one isn't? Since those aren't corresponding, then these triangles are not congruent, okay? So not congruent, does not work. Let's go ahead and prove this. It says prove FH is congruent to JL. FH congruent to JL. It's telling us that GH is congruent to KL, GFH is congruent to KJL, FGH is congruent to JKL, and we're proving FH is congruent to JL. So step one, again, just for the sake of time here, I'm just going to try to draw an arrow to the given, but you could write that all down as step one. Step two here is to use our congruence criteria theorems, right? So side, 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 angle, side, angle, side, angle, or angle, angle, side, to see if we can prove these triangles congruent. In order to say parts of a triangle are congruent, we need the triangles to be congruent themselves. So that's what we're trying to do. We want to make these triangles congruent, and then we can focus on this. So for now, what we're trying to prove eventually is just on the back burner. Step one, we want to prove these triangles are congruent to begin with. So here, you can see we have an angle and an angle. F is congruent to J, G is congruent to K, and then GH is congruent to KL. So you can see that these triangles are congruent because of angle, angle, side. So let's say it. triangle FGH is congruent to triangle JKL because of angle, side. Okay? Or side, angle, if that's how you saw it too. All right? So now that we have these two triangles are congruent, we can then say step 3. Oh, look, we're trying to prove, this is what we're trying to prove. We're trying to prove FH is congruent to JL. Well, those are corresponding parts of congruent triangles, right? So don't we have a theorem that says that? Yes, we do. We can say FH is congruent to JL, FH congruent to JL, because of corresponding parts of congruent triangles are congruent theorem, okay? Corresponding parts of congruent triangles are congruent. So that makes FH congruent to JL, since those triangles are congruent. Another little example, it says, given the figure, what additional information is needed to show triangle ABC is congruent to triangle DEF by angle, side, angle? In order for that to happen, angle, side, angle, we need two angles and the side in between them. So it looks like angle B would have to be congruent to angle E. And part B here, it says what additional information is needed to show ABC is congruent to DEF by angle, side. Here you need two angles and a side not in between those two angles. So let's say we have angle C congruent to angle F. All right, that would be how you solve those two. All right, last little proof here. I say little, it is kind of little, I guess, relatively. This says prove the angle, side theorem. So we're trying to prove that two triangles can be congruent because of angle, side congruence criteria, okay? So what we cannot use in this proof is the angle, side theorem. That's the only thing we cannot use. Step 1, it kind of tells us everything we need to know to start. So angle P is congruent to angle S, angle Q is congruent to angle T, and then QR is congruent to TU. That all is the given, and that's just what I'm going to write down first, okay? Okay, so for step 2, what I want to do is I just want to say, just in case we might need it, I just want to say angle P, the measure of angle P, equals the measure of angle S, and the measure of angle Q equals the measure of angle T. Just in case we might need it. We might not, but it's not a bad thing to write down just in case, okay? So that's the definition of congruent angles, or definition of congruence, okay? Definition of congruence, all right? So since those angles are congruent, we know the measures of them are equal, okay? The next thing I want to do is step 3. What I want to do here is think a little more abstractly, because the given doesn't really tell us much more, the diagram doesn't really tell us much more. So what I want to remember is the triangle angle sum theorem, okay? This says that all the sum of the angles of a triangle add up to 180 degrees, okay? The sum of the angles of a triangle is 180 degrees, okay? So if we added up all the measures of the left triangle, let's say the measure of angle P plus the measure of angle Q plus the measure of angle R equals 180. We can also say in that same step the measure of angle S plus the measure of angle T plus the measure of angle U equals 180 for the same reason. This is the triangle angle sum theorem, which just says all the angles of a triangle add up to be 180 degrees, okay? I want to really focus in more on steps 2 and 3. Step 2 says the measure of angle P equals the measure of angle S, all right? So let's kind of highlight that. The measure of angle P equals the measure of angle S. Now I'm going to highlight all my measure of angle P's and all my measure of angle S's both yellow, just to signify that they're kind of the same thing. Let's also do the same thing for the measure of angle Q and the measure of angle T. Let's highlight those blue, just to signify that they're the same thing. Okay, so if we're looking at step 3, let's say we have yellow plus blue plus the measure of angle R equals 180 degrees. And then we have yellow plus blue plus the measure of angle U equals 180 degrees. Both these things are equal to 180 degrees. So what I want to do is use substitution to say, in step 4, the measure of angle P plus the measure of angle Q plus the measure of angle R equals the measure of angle S plus the measure of angle T plus the measure of angle U. So since both those equations in step 3 equal 180 degrees, we can set those things equal to each other by substitution. And I'm going to keep my highlighted measures there as well, just because I think it's going to make it easy here. So imagine we have both sides of this equation. I've written them kind of awkwardly on top and bottom just to make it easy to fit in there. But imagine we have both sides, okay? Here we have on the left side, or the top side here, we could say yellow plus blue plus the measure of angle r equals, now on the bottom or the right side, yellow plus blue plus the measure of angle u. So since we have yellow and blue on both sides of this equation, we can subtract yellow and blue from both sides of this equation, since they're literally the same thing, right? So we can use subtraction to say in step 5, the measure of angle r equals the measure of angle u. Right? All we did was subtraction. There we go. Subtraction, property of equality, actually. We did subtraction to subtract the yellow angles, which were the same, and the blue angles on both sides of the equation. It's just like saying if you had x plus 5 equals y plus 5, you would subtract 5 on each side to get rid of those 5s, right? Now, step 6, if we have two measures of an angle are congruent, we can say those angles themselves, if we have two measures of an angle are equal, then we can say those angles themselves are congruent. So angle r is congruent to angle u. That is because of the definition of congruent angles, or definition of congruence. Okay? And what I want to look at now, I don't even really want to look at it. I just want to make note that I said that angle r is congruent to angle u. And look, when I made note of that, I saw that angle r is congruent to angle u. Angle q, not angle q, qr is congruent to tu. And then angle q is congruent to angle t. So, kind of just out of the blue here, just out of nowhere, now these triangles are congruent because of angle side angle. And is that what we were trying to do? Yes, it is. So angle side angle is going to be our last step. We can say, number 7, what did it want us to do? PQR and STU. Triangle PQR is congruent to triangle STU because of, what was it? Angle side angle. Huzzah!